Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the constant of integration. This is part 2. If you haven't checked out part 1, I encourage you to do so, for it carries a lot of insight. Now, recall from the Introduction to Integration video, if dy dx is equal to f prime of x, then the integration of dy dx is equal to the integration of f prime of x dx. That giving us y is equal to f of x plus c, because we are simply reversing the differentiated function and adding the constant of integration, the c. Now, if a point P with coordinates x0, y0 lies on a curve y, then substituting for x with x0 and for y with y0, we get y0 is equal to f of x0 plus c. Then solving for c, we get c is equal to y0 minus f of x0. Then substituting for the c back into the y equation, we would have y is equal to f of x plus y0 minus f of x0. Let's take a look at example 1. The equation of a curve is such that dy dx is equal to 4x minus 3 square root of x plus 1. Then we are given that the curve passes through the point 4, 11. Find the equation of the curve. So recall from the laws of indices, we can actually express dy dx as 4x minus 3 times x to the power half plus 1. Then we integrate. That would give us y is equal to the integral of 4x minus 3x to the power half plus 1 dx. And recall from our part 1 video on how we integrate, then what we would have is a 4 over 2x squared minus 3 times 2 over 3 times x to the power 3 over 2 plus x plus c, the constant of integration. Now simplifying that, we would get y is equal to 2x squared minus 2x to the power 3 over 2 plus x plus c. We go on to substitute for the coordinates, the x is equal to 4 and the y being equal to 11, so that we get that, and then we solve for c, and our c comes out as a minus 9. Then we take that minus 9, we substitute it into the y equation, so that we get the final answer as y is equal to 2x squared minus 2x to the power 3 over 2 plus x minus 9. That's how we go about it. Let's take a look at example 2. Find the equation of the curve given dy dx is equal to 2x times 3x minus 1 and a point P minus 1, 2 on the curve. So the solution here. Remember, we haven't learned about the substitution method as yet. So we are going to make use of the expanding of brackets, because that is what we have at our disposal at the moment. When we expand the brackets, we would have dy dx to be equal to 6x squared minus 2x. Then we integrate the terms separately, so that we have 6 over 3 x cubed minus 2 over 2 x squared plus c. Simplifying that, we would get y is equal to 2x cubed minus x squared plus c. Now we substitute for the x coordinate and the y coordinate. Those were minus 1 and 2, so that we get our c to be a minus 9. Now we substitute for the c into the equation that we obtained for y. then we would have our final answer as y is equals to 2x cubed minus x squared plus 5. Let's jump to example 3. So with the example 3, we have find the equation of the curve given dy dx is equals to 2x cubed minus 6 divided by x squared and a point P 3, 7 on the curve. So now we separate the numerator because it's easier to do so at this moment. But of course, later on, we would learn about how to use integration by parts. So I encourage you to subscribe so that you don't miss out on any of our future videos that will cover some of these techniques. Great. So our dy dx separated would give us 2x cubed divided by x squared minus 6 over x squared, and that simplified would be equal to 2x minus 6x to the power minus 2. Remember the laws of indices that we spoke about. Then we integrate what we have as our new dy dx. Nothing changed really, but just simplifying of our work. So now we get that, and when we integrate 2x, we get 2 over 2x squared minus 6 over minus 1, x to the power minus 1 plus c. Right, simplifying that, we would get y is equal to x squared plus 6 over x plus c. And substituting for the x and the y coordinates, which were 3 and 7, we get our c value to be a minus 4. So we substitute for that c value so that we get our y to be x squared plus 6 over x minus 4. Right, as simple as that. Let's dive into example 4. So with example 4, find the equation of the curve given dy dx is equal to 1 minus root of x squared all over the root of x. So that is passing through a point P with coordinates 9, 5 on the curve. So we would know that it will be easier for us to separate the numerator, or rather expand the brackets to simplify our work. So if we do so, we are going to have dy dx given in that form. Recall from the laws of indices that root x becomes x to the power minus half. And then when we multiply the square bracket or parenthesis times the x to the power minus half, eventually we would have a situation we have here of dy dx being x to the power minus half minus 2 plus x to the power half. Now we move on to integrate these terms separately. If we do so, we're going to get y is equals to 2x to the power half minus 2x plus 2 over 3, x to the power 3 over 2 plus c. Now we substitute for the x and the y coordinates 9 and 5 so that we get our c value to be minus 1. Then we substitute for the minus 1 is our c. We get that final equation. So that's how we would go about the tasks. So if you've made it thus far, thank you so much for watching Numbers Simplified. I'll leave you with this particular task. I'll be glad to hear of how you executed this task. Remember, your feedback is always welcome here. Remember to like, share, and subscribe so that you don't miss out on our future uploads. Thank you so much for watching Numbers Simplified. God loves you.